So I wanted to take the chance to explain how the population growth exercise works because it's usually a source of confusion. And it's important. It's an important exercise because it will let you think about this iterative process both from a conceptual standpoint to understand it, understand how it works and what it's asking for, and also, of course, how to uh, transfer that concept, that knowledge, that understanding to Python code, which is of course ultimately what you want to do. You have your ideas in your mind and you want to be able to write them in actual Python code. So the population growth assignment is it asks you for how much time it's gonna take for a population to reach a given target, right, that we are defining. So we have an initial population size. We start for example, we are a community of 5,000 people, and it says that we are growing 10% every year, for example. And the question is how many years it's going to take us in order to reach, for example, 10,000. The important thing here is that these are kind of compound interests, right? The 10% of 5,000, it's going to be, we can start actually making some tests. 5,000 times 0.1, it's going to be 500. So the next year we will be 5,000, sorry, and 500 people. But now if I increase 10% of that, we are now 550. So we've grown even more than previous year. I mean, the growth is the same, 10%, but as the initial state of the population is larger, the absolute number is going to be larger. So let's understand it conceptually. Again, the idea is that we have an initial population, we're 5,000 people, we're growing at a 10% rate per year. How many years? That's the answer. How many years? 2 years, 5 years, 8 years? How many years is going to take us to reach that target population that we want to reach? So we start with a few variables, and here is when the iterative process starts, and it's going to be kind of these things that we're doing right here. So I'm going to modify this initial value, and I'm going to start doing something like, what I could do something like, for example, year 1, in our first year, we will grow, right? So new people, it's going to be the initial population times the growth rate. And that's going to be new people. We're going to just show it to you here. It's going to be 500. So after the first year, we will have this initial, of course, nobody is dying, nobody's leaving town. We have this initial population plus these new folks right here. So at the end of of year 1, we will have new people plus, and I'm gonna delete this one, initial. This is gonna be our new population. So I'm gonna keep these kind of in a separate variable. I can keep, for example, I could initialize here current population, just current equals initial. And here we're gonna start using current, and I'm gonna do current is equals the new population, the new people, sorry, plus current. We're just increasing. So now current is gonna be it's gonna be 500 and 5,500. So now year 2, and let me copy this again. Year 2, it's going to be, let me change that. It's gonna be new people. And let me comment it so we don't see any repeated values. So we are increasing now. We had 5,500 people, and now we're increasing 10% of that. So now new people, it's going to be 550 new folks. All right, so we're increasing 10%, but again, the base or the initial population is larger, so this number is larger. So what I'm going to end up doing is just renaming, or pretty much doing this same thing again and adding it up, and now we went from 5,500, we added 550, and we ended up with 6,050. So if we do these, we repeat this process again, and I could here copy this here, and I get this one here. If we add 10% of these, we're now adding 605 new people. All right, so again, we're growing 10%, but we had a larger base, so the number at the end is larger. And I'm gonna get this one again, and I'm gonna just add these new folks to our current base. So we have now, after year, this is going to be year 3, we have 6,655 volts. So now let's copy this over again, and now we have here year 4, and out of 6,655, we add 10% of that, and this is the new number. If we add that to the target one, we will end up with 7,000, right? So we are pretty much making this process over and over again. So this is going to be year 5. There you go. Year 5, we reach 8,000. Again, remember our target population is 10,000, right? So we are adding 10% to our base of population every year. So this is going to be year 6, and this is going to be now. So now we're closer to 9,000. This is going to be year 7. We're pretty close. I know the answer already. So this is going to be year 7. We have 9,743 people. So we are close to the to the target, which is 10,000. If I add one more year now, if I wait one more year at this same growth rate, I end up with 10,700 people. So I have just reached the target population. How many years it took me? Well, we've been counting them. It took us 8 years to reach this population. So again, every year we're still increasing 10%, but as the number gets larger, that 10% of course is larger in absolute terms. If you pay attention to these cells, to all these cells, they all have the same code, right? So I could have done a simple loop, right, iterating over these over and over and over again. And if you remember our explanations, I told you, right, when you had something like, for example, you wanted to print hello world, hello world 3 times, right? So you have these 3 times that you could, whenever you see something repeated, you can put that thing in a block, right? So repeat, this doesn't exist, repeat 3 times. That, of course, again, repeat 3 times doesn't exist, so we need to somehow use a while loop in order to, or a for loop in order to overcome these limitations. So here we could do something like for I in range 3, right? And it's going to be the same result. Or we could have initialized something like, I don't know, while count equals 0, while count is less than 3, print hello world count plus equals 1. So we can do pretty much the same thing with a while loop. The difference between while loops and for loops was, remember that with a for loop you knew upfront how many times you wanted to iterate. So with this example, a for loop is more convenient. In this case, we don't know how many times we will end up repeating, because it depends on how the population is growing. Of course, we have a formula, right? So if we wanted to more or less naive version of this solution, we could have computed upfront how many times, how many years it's gonna take us. But with this kind of naive approach, when we're starting the iteration, we don't know how many years it's gonna take us. So that's why for this assignment, it's much better to use a while loop instead of a for loop. And basically, you want to put these blocks in your while loops. So it's going to be something like these for both of them. It's going to be something while. And I'm going to put it here more conceptually. We will translate it into real code later. While we haven't reached population target pop, we're going to do now this and that. All right, so while we haven't reached the target, we will keep growing, we will keep adding up, and each one of these things is going to be a year. So we're going to keep here years equal 0, for example, and after each one of these passes, we will reach year plus equals 1. So this is basically what we want to do. And if we focus now in this condition, it's relatively simple to think about it. It's what's that condition? We haven't reached target population. How can we express that? Well, you can just use numbers, right? So we have target, which is the number, 10,000, and we have this number right here, current. current. So we can ask, for example, while current less than target, right? And this case is going to be false, of course, because we have just reached it. So we can say just while the current population is less than the target population, keep iterating, keep adding new people every year, keep increasing the years, and finally print, for example, the years to see them. All right, so this is what we want to do. If I run now these, it's not going to work because the population is already 10,000. I'm just going to go and do it. So it took us 0 years because we already have 10. But if I initialize it again with current equals 5,000, as we started it, there you go. It took us 8 years to reach that number or that population target that we had, right? So this is basically what the assignment is asking you to do. Of course, you need to wrap this up in the function definition. So it's going to be something like this. We have that, and we need to, of course, initialize the correct variables, and at the end you need to return the number of years, because this function is asking you for a final result. It's not asking you to print it. Remember, don't print in your functions. We need a final result out of this function, and you need to use the correct ones. And I think that you have one more thing to check here, which is an invalid population growth. So if in this case you receive that annual growth rate is 0, you should be returning invalid growth rate instead of processing it, because in other case you will get stuck in this infinite loop forever, because new people will always be 0, and you will again keep iterating in an infinite loop. So again, this is the idea of the population growth exercise. And aside from this population growth one, what we want to show you is, again, whenever you're realizing that you're iterating or you're performing the same steps over and over and over again, these are literally the same rows over and over again, it's a good candidate for an iterative block, a while or a for. And one more thing, how do you differentiate between for and while? Again, when you know how many times you will be repeating, maybe you don't know it when you're writing your code, because you're asking the user how many times do you want to see something. But the user is going to tell you. So at that particular point in time, the program is aware of how many times. So you can use a for loop for that. If you don't know upfront how many times it's going to take your iteration, then it's a good candidate for a while loop. Usually you can kind of use both of them, but there are sometimes when one is going to be better than the other.